Hello, everyone. Swayam, can you just give me a heads up if I'm audible?
Yeah, Anisha, you're audible. You can go.
Cool. So, hello, everyone. Good morning. I am Anisha.
And I'm Sam Siddharth, and we are your hosts for the day. So, on the behalf of entire team of TensorFlow User Group Bhubaneswar, in collaboration with GDG Bhubaneswar and GDG Cloud Bhubaneswar, we extend our heartiest welcome to all of you for making some time for our event, Keras Community Day 2023.
Keras Community Day 2023, Bhubaneswar, is a one of a kind event that brings together AI enthusiasts, machine learning practitioners, developers, and technology aficionados under one roof. Today, this event is all about exploring the limitless possibilities of Keras, a high level neural networks API that simplifies deep learning. So, without any further ado, let's welcome our very first speaker for the day. So, first up, we have Mr. Vrijraj Singh. Vrijraj is a dedicated tech lead at Agrok who is deeply passionate about fostering community management. With an impressive 7 year tenure as an organizer for GDG Jalandhar, he has a remarkable record of coordinating 400 plus events and conferences. As a recognized Google developers expert in Firebase and web technologies, he has shared his expertise through 300 plus tech talks and workshops. Vrijrat's proficiency spans across web development, Firebase, Google Cloud Platform, and UI design, UI UX design. In today's session, he is going to speak about few valuable insights on building web solutions using machine learning. Without any further ado, over to you, Vrijraj. You can get started.
Yeah. Hi, team. How are you? I guess like I'm audible, right?
Yeah, Vijay, you're audible.
Yeah,
Yes.
Vrijraj, you're audible.
Okay. My screen is visible, I guess. Yeah. So perfect. So hi everyone. My name is Viraj, and I'm a Google developer expert for web technology and Firebase. Also, I'm leading tech firm and community. And talking about my professional point of view, so I'm a tech lead at AppProp, which is a real estate-based company. So today in this talk, I'm going to talk about how we can build web solutions with the help of ML. Like there are a lot of things, and there is a buzzword is going on in the market. ML is doing a lot of things, so we can make the solutions with the help of web, and we can provide more capabilities for the web platform. So talking about the step by step, like first I'll talk about the state of the web in India, like how web developer can enhance the ecosystem for the India, and then we'll talk about the machine learning part, like how we can use the power of machine learning and we can enable the web platform more enhanced or suitable way, and then we'll talk about like how we can create a sample applications with the help of machine learning. So, I'll start with the state of the web of India. Like if I talk about the developer ecosystem in India, so there are around 932 millions monthly active users are using internet, over 930 millions monthly smartphone over monthly point of view. So here we have a huge opportunities, like we as a web developer or maybe the mobile developer can build the solutions for the Indian developer ecosystem, and we can enhance and we can improve the developer ecosystem. So talking about specifically for the web platform, like web has a lot of things. Like web is just like as a platform where we can share the informations with the help of network can be anything, it may be around internet. So you can share the informations like PDF, image file, audio file, text file is all about the web. So web is just like as an information system. And talking about specifically for the web ecosystem, so we are accessing or sharing information with the help of internet. So internet is just like the network. So we can access this internet with the help of these submarine cables. So when you go to the internet, like over any website, you are watching any website, let's say YouTube or maybe any like social media website. So you are accessing the information through these submarine cables, and like these cables are connected with multiple continents. Like you can check out the map, submarinecablesmap.com. Here you can find multiple informations. Let's say I have a server in, let's say, Europe region, and I'm accessing my website in India region. So my internet is the website is coming from this particular way. So this is just a simple example like how internet is working and how we as a developer or maybe individual user are accessing these informations. So the next one part is about the web. Like web has a lot of capabilities, like we can build the solutions. So talking about specifically web, so web has three core fundamentals. Like the first one is the website, where we can create a web page where user can see the web page, the website, and we can create a web page with the help of HTML, CSS, and the JavaScript part. And then we can test our website with the help of browser. So browser is just like as a the program where we can access the web page and we can see the web page with the help of browser. The third one part is the server where we can live our website, where we can upload our HTML, CSS, and the JavaScript code. So this is a basic fundamentals about the web platform, like how web is working and how the web core component are connected and how we can see the information with the help of network and the web. So so if I talk about the web perspective, the developer perspective, so web has a lot of variety. Like we can build any solutions, we can develop uh, anything with the help of any technologies. Like it's just like as a we have a dependencies. It's just like as a browser. So with the help of browser, we can access the informations and we can do a lot of things. So like in the web, like we can work on as a web the front end developer, where we can work on the UI UX part. And talking about the back end developer, here we need to work on the back end business part, like maybe like database server, or maybe you need to create a REST APIs. And the third one part is more about the full stack development. Here you just need to focus on the front end technologies or the back end technologies as well as. So this is just an overview about the web developer ecosystem. Now let's talk about like how we can get more user. Like if I talk about, there is a buzzword is going on, machine learning. So let's talk about the machine learning capabilities. Like with the help of machine learning and the web platform, what type of things we can implement and how we can enhance the user experience, how we can provide better like features with the to the users. So let's talk about the machine learning capabilities. And if I talk about the machine learning, so I have only one word, like the Python and the model. And there is a lot of things, like whenever we as a machine learner we work on the Python part, we need to install a lot of libraries. It may be around Python, it may be around pip, anaconda, numpy, scikit-learn. There are a lot of things. When you install it on a local machine, there might be possibilities like my system is going to tell you that's it, you can't do anything. So if I talk about for the web developer point of view, so yes, there is a library that you can use, TensorFlow.js, which is a machine learning library for the JavaScript. You can run your machine learning code over the browser, and it's just like as a client side library, or you can use this library over the server side as well as. Uh, Here it's just like as a bootstrap. Like if you are using bootstrap or maybe front end UI developer library, you just need to like include the CD. And similarly here in the TensorFlow, here we have a node package manager or the client side library. And with the help of TensorFlow JS, you don't need to install any such kind of dependency. You just need to work on the web platform, the browser part, and you can work on the TensorFlow. And you can write one time and you can use this library multiple platform. Like it's the TensorFlow is the JS library is accessible all across the browser, and you don't need to install anything. You just like focus on the machine learning part, the model. Here we have a predefined models. Here we have like you can create your own model and you can work on it. So there is a three things, like you can use predefined model is just like just the postnet detections. There are multiple things you can integrate these model or with the web platform, and then you can provide better user experience. And the third one part is like if I talk about the pre-made models defined by the TensorFlow.js library. So here we have a vision, means the image classifications, object detections. If I talk about human body, so here we have a body segment pose detections. Let's say I'm changing my gestures, like so you can detect the pose, you can check the face mark. So there are a lot of things with the help of TensorFlow.js. Here we have a pre-models. that you can use, and you can enhance the better user experience whenever you are working on a web platform. So, like this is example for the postnet detections. Like this is built with the TensorFlow.js library, so you can detect the pose and you can do a lot of things with the help of web platform. So there are a lot of things like postnet, the face detections. You can do multiple things. So you can find more information about TensorFlow.js. Just go to the website TensorFlow, and then you can find the link for the library, for the JS library. Now, I'll talk about another thing is more about the Palm APIs, Palm. So, which is most trending topic as of now in 2023. As of now, like there are a lot of users who are accessing ChatGPT, Bard, or maybe any Mid Journey for generating images, maybe generating a content. So, talking about these APIs, like the Palm is like the large language model provided by the Google itself, and Palm 2 is the next generation large language model where you can do a lot of things in terms of you can generate the text, you can estimate, you can like do multiple things in terms of text point of view. uh, so talking about specifically for the Palm 2 APIs, so Google has introduced the four models like the Gecko, the Octa, Bison, and the Unicorn. So Gecko is specifically for the smartphone devices. Let's say if you are using any smartphone and you wanted to use the machine learning concept. So here we have a Palm 2 APIs, and then you can use Gecko model. Or if you want to use more like resources or more capabilities or more performance or the more complexity part, then you can use Octa. And the Bison is for the developers. Like we can do a lot of things in terms of the large language. So Palm 2 is specifically for the Bison as of now, and there is another model is called as Unicorn. So as of now, which is not disclosed, Google is working on Unicorn, and maybe upcoming year you will be able to find the informations about the Unicorn model about the Palm 2 APIs. So if I talk about specifically like how we can access this Palm 2 APIs, means the large language model. So we can work on the Python part. We can do a lot of things. But if I talk about for the developer perspective, so here we have a maker suite. It's just like as a platform where we can access the Palm 2 APIs. We can create a prototype. We can create a machine learning like based web applications within a not millisecond, within a minute. Here is just like as a dashboard where we can find the informations. So I'll give you the demo instead of showing the informations over the slide. So this is a maker suite. Here we can create a prototype. Here we can work on the ML part. Like let's say I don't have any experience about machine learning. I wanted to use machine learning concept for the web platform. I wanted to make the applications. So I can go to the maker suite website, and here we can generate we can do multiple things. So here we have a three parts like the text prompt, data prompt, and the chat prompt. So text prompt is more about the informations. Let's say I wanted to go let's say Bhubaneswar. So I have a 7 days. I have a set of limited budget. So I can like go to this particular text prompt, and I can like get the recommendations like what type of things I can do, what type of itinerary I can follow. So we can do multiple things. So I'll give you the demo. I have created this demo, the trip planner. I guess like this screen is visible. So like I'm a GD and I'm a traveler, so I love to travel a lot. So I have used these Palm 2 APIs, and I have created these applications for me. Like whenever I go to the different cities, so I have some sort of limitation in terms of budget, the days, number of days, and the food selections. Like I'm a vegetarian, so I'll type, but let's say I'm going to Bhubaneswar. So I have a 7 days, and I have a budget around let's say 20,000. I'm a vegetarian, so this model will suggest me like what will be the travel itinerary and what will be the hotel, what will be the day wise itinerary like I can follow. So this model is right now considering as a origin as a Delhi, like I'm from Delhi, and this model is recommending like yeah, in Delhi you can go to the Bhubaneswar and you can find a hotel, and you can do multiple things. So this is just a example like how we can enhance the web platform with the help of machine learning and the Palm 2 APIs like the Maker Suite. So talking about specifically for the Maker Suite, So here we have a three type of prompt you can do, like the text prompt. So I'll go to the text prompt. So here you can define the text. Let's say you can share like show me the travel for, let's say, Pune from Delhi for, let's say, 5 7 days. So I'll run this model, and this model will recommend you to the best suggestions, like with the help of palm to apis. So yeah, so this is a markdown language. Here we can integrate this language. There are multiple libraries that you can integrate, and this is a result. So like this is just a simple example, like with the help of this maker suite, how we can enhance the better user experience for the developers or the end users. And similarly, there are multiple examples, or like there are multiple prompt suggestions. Let's say this is not a good, then you can use this particular prompt, and then you can work on it. Similarly, there are the prompt suggestions. There are number of prompts they have defined as of now. Let's say I have a large text, I want summary, so you can go with this particular model, and then you can create a summary. Okay, so let's say like I have designed this particular prompt, let's say for the travel itinerary. I'll run this particular prompt. Just a minute. Yeah. So this is my prompt, like write a traveler itinerary for 7 days from to Pune from Delhi. So this is a prompt is recommending this particular content. So I wanted to integrate this content like prompt for my web platform. So you can go with the code part. So here we have a code. You can integrate this palm to apis with these language. Like if you are working on a javascript, if you are working on a python part, you can use this library. I'll show you the demo, like how we can use these palm to apis, like how we can make this the integrations part. So first one is more about, like first we need to import the node libraries, is all about the text service client. And the second one is for the authentications, the Google Auth authentications. And then here we have a model, as I mentioned, like Google has introduces the four models like Gecko, Octo, Bison, and the Unicorn. So right now we are working on a Bison model. So here we have a Bisons, and here you can add APIs, and then you can define the client. And this is just like as a functions where we have generate client text. And here in the sections for the prompt, here you can define the prompts. So I'll share the entire screen. I'll show you the example, like how these things are working on it. Okay, I hope my screen is visible, right? So like this is a Node.js. I have integrated this PAM to APIs in my backend. So I have created a controller where we can get the information. So here we are getting a prompt. So like here first we have loaded the libraries for the Node.js and the Palm to APIs. So that's a generative AI model. And then we have defined the model, and then here we have APIs. And this is my controller. Inside controller, we can collect the informations like this is here I am passing the place, number of days, and the budget, and the selections. So here we have collecting informations from the body. And then here we have defined the prompt. So my prompt is create travel itinerary from Delhi to this particular place for these days, and I have a budget, it's about Indian rupees, and for entire day. Okay, so this model is and then here we have a list of parameters. Like first we need to define the model. So here we have defined the models, and then we can control the temperatures, the token, we can do multiple things, the safety related to the prompt. And then here we can define the prompt, and this model will create a result, and then you can integrate the result with the front end part. So this is a travel itinerary platform. So like this is how we can use the concept of maker suite, and then we can create apis. So I'll show you the maker suite platform. Like here you can do a lot of things in terms of text modeling, data prompt. Like you can define the multiple data, and you can get the table type of format, type of data. You can do a lot the chat type of prompts, like I can do conversational type of things with the help of chat prompts. So here in the API section, you can get the APIs for your model, and then you can integrate these APIs for the front end, and then you can do multiple things. Okay, so this is all about the maker suite. So like this is a the simple applications I have created with the help of maker suite and the web platform like the trip planner, where you can get the recommendations for your traveling plan. So like again, this is a simple example like how we can perform these operations. So first we need to load the Node.js library for the Google Auth and the Palm 2, the generative AI concept. And then we need to define the model API key, and the next one part is for initializations. And then this is a simple code as I might show you, or the code part, like how we can enhance, how we can access this particular, call this model. So the next one part is about the machine learning part. So like there are multiple predefined APIs that you can use power, which is provided by the Google Cloud Platform. Like you can use the face detection APIs, label detection APIs. This is pre-built APIs. You just need to call these APIs in your web applications, and then you can enhance your the experience. This is like you can detect the face, label, OCR, safe detection, landmark detections, or maybe the logo detections part. And then we have APIs like barcode APIs, like you can detect the barcode and you can do multiple things. You can check the text over the images and extract the informations. And yeah, for more informations about the TensorFlow, you can check out the link tensorflow.js. And for MakerSuite, you just go to the website makersuite.com, makersuite.google.com, and you can apply for the access. Right now, it's early access, so you can be in a waiting list, but you will get an access within a few business days. And there is a more informations like about the AI, what's going on in AI. So you can check out google.ai is the website. Here you can find multiple informations. Let's say if you are working on Python, if you are working on a web platform, if you are working on multiple things, you can find the deep informations in terms of blogs, in terms of the resources, APIs, the developer platform. You can find these informations over the Google AI platform. And yeah, so that's all from my end. Is just like is in the sessions, like I'll show you the simple example, like how we can create a web solutions, how we can integrate the maker suite APIs. Like it's just like it's an API platform, the prototyping platform for the Palm 2 APIs. And we can create a prompt, we can integrate these prompts with the help of the code part, the library, and then we can create applications. So I hope you have enjoyed the sessions, and thank you so much, GDG and the TFGG Bhubaneswar team for inviting me. And yeah, thank you.
Thank you so much, Raj, for that remarkable session. Like it was really delightful to have you. I'll just ask. Let's wait for a few minutes if there are any questions in the chat box. Shall we? Yeah, there is a question from Shubham. Okay, Rajat, there is a question for you from Kumar Shubham. So Kumar Shubham is asking, can you come give some insights about how to integrate TensorFlow JS in our website?
So TensorFlow JS is a JavaScript library. Like if you are working on a Bootstrap, so here we have a CDN that we need to integrate in our HTML part. So similarly, TensorFlow.js is a JavaScript library. Here we have a library is just like as a CDN, or you can use Node.js module. Like they have defined the Node.js library for the TensorFlow.js. So you can integrate and you can follow the documentations. Here we have a lot of predefined the model that you can use. I can give you the example. Like this is a website for the tensorflow.js. Here you can go to the demo part. Here we have a lot of documentation demos, like the holo booth, lip sync for the YouTube, and you will find the doc code is itself. Yeah, as I mentioned, like it's just like as a bootstrap the JavaScript library. Similarly, we can import this library in our HTML code, or we can install the node.js part, like yeah, the node.
Cool. There's another question from Saurav Dev. Saurav is asking, Sir, how can we integrate the TensorFlow.js model created in Collab and then add it to the React website?
Yeah, you can do multiple things. Like as a developer, we need to work on the module part. Like it's just like a small set of functions. We can pass the data from one functions, and we can collect the information, and we can through pass the information to the another function. So yes, OpenAI is also providing a multiple the facilities where we can enhance the better experience for the help of machine learning. So like you can do multiple things. Like again, these two are different things. You can do, let's say, you can summarize the text with OpenAI as well as similarly for the MakerSuite API.
Great. Another question from Kumar Shivam. How can we integrate OpenAI library with TensorFlow.js to build web solutions?
Yes, the same part. Like they have a documentations, and they have a like they have shared the informations. Like it's all about the thought process, the problem you are solving. So let's say I for let's say the text summarizations, I can use OpenAI. For let's say the content generation, I can use the MakerSuite. So like I can get the informations from the OpenAI, and then I can pass the informations. So you can do these kind of things.
Right. There's a question from Pratik Davidson. So Pratik
Yeah.
Davidson is asking, Hi, can you explain a little bit more about the model types, Gecko, Bison, use cases and all?
Yeah. So this is a part of the Palm 2 APIs, the large language model. So as of now, Google is working on the four type of models, like the Gecko. Gecko is for the smartphone devices. Like let's say I have a smartphone, I wanted to run the machine learning model in my smartphone. So I prefer to use with the Gecko model. So Gecko has like less capabilities, but I can run this model with the mobile devices because I have a lot of restrictions in terms of the hardware. Then if I talk about the next model is for the octa is more about, let's say, smartphone, more than smartphone, but yeah, let's say it can be around the laptop or maybe the tablet part. So then you can use octa model. And the bison model is more about like the web platform. The as of now we are accessing informations. So bard is an example for the palm 2 apis, and it may be around the bison plus uh, the unicorn is the big giant model. Right now they are working on it, and the bard is part kind of this particular example.
Cool. Any more question, guys? I guess that's all. Thank you, Rajat sir, for
Yeah,
answering the questions of our audience. We would love to see you once again later. And that's all. Thank you.
thank you so much for having me. Yeah,
Cool. So thank you guys for being engaged in that session. We have a quiz coming up for you. Anisha would tell you more about it.
So it's very simple. We have it in Slido. We usually do it there only. Swam, can you just share the link here, or just share it so everyone can see and we can go further ahead with it?
Yeah, I Yeah, yep. I guess my screen is visible now.
Okay, so everyone watching here, you can scan the QR code or you have the hashtag number. You can simply go in the website and you can join us there. We'll be waiting for a few minutes and then we can get started with the quiz. For everyone joining in, you can scan this QR code here or you can simply log in by the website. All the links, all the data is in the screen itself. You can view them.
Okay, I have started the word bubble right now. So we guess we can start interacting.
Okay, should we take a little time, or should we just get started?
We should take a little and let's see the names on the leaderboard and then we will start.
Yeah, yeah, great. Everyone in the audience, you can start joining. We're waiting, and we'll be starting in a few minutes.
Hi Nirakar, hi Anubhav, hi Saurabh. Little much of surprise. We have cool goodies for all our quiz winners who will be winning today's quiz. Hi Mrinal, hi Devdatta, hi Adarsh. Okay, there are a lot of names now.
How about we start at 10:42? We just start in 2 minutes. That's fine, Swam.
Yeah, looks good to me.
Yeah, yeah, okay. We'll just wait for another 2 minutes. Wait for everyone to join in, and we can get started.
I guess we should start. What say, Anisha?
Yeah, yeah, sounds cool to me.
We have 13
Uh,
participants in the quiz, and
okay, let's just
I
wait for
guess,
the clock to tick to 10:42, and we can get started.
yeah.
Okay, so we have our participants here. I think we're good to go now. Swam, we can get started.
Cool then. So let's have our first question. So, which company developed the first mobile phone? Options are Motorola, Nokia, Samsung, and Apple. Guys, fast on your Slido screens. Okay, so equal
We
number of
have,
participants with Motorola and
yeah, Nokia. So let's see which one's the winner. Okay, Motorola is it. It is.
yeah. Okay, cool. Next question.
Just a second. Okay, we can go ahead and that. So this question is very simple. What is Keras? The options are a machine learning library, an operating system, a programming language, a database management system. Okay, so majority have gone for a machine learning library. Thank
I
God,
guess
everyone, 100%.
that's it.
Our audience is really talented. So, yeah, you can
What
take
is the
a you.
primary purpose of a machine learning model? To make predictions or decisions based on data, to execute tasks without human intervention, to create beautiful visualization, or to store and retrieve large database sets. Okay.
Okay,
Shall we see the answer? What's it?
yeah, let's go ahead. We have 80% people going for option A. Yeah, that's correct. Wait, just before we move ahead, I have to say us a little something. So, everyone, those who are participating in this, the you need to answer these as soon as possible. The fastest one who will be answering the most questions right will be the winner. So that's what I had to say. We can go ahead with the next question, Soya.
Cool.
Which of the following is not a supervised learning task? Image classification, text generation, regression analysis, spam email detection. 90 seconds, 9 seconds to go. I'm really sorry. 9 seconds to go. Three more.
Okay. Lot of confusion.
Too much confusion, yeah. Text generation and regression analysis. Which one do you think Swayam answer is?
Text generation. Quiz moderator is always right.
Okay. Let's go ahead and check the answer. Okay, so as our quiz moderator is right.
Cool. Let's move with the next question.
Yeah.
In Keras, what is a layer in a neural network? A group of data points, a single neuron, a model building block for computation, a type of machine learning algorithm. Guys, quick. This is an easy.
Okay, so 44% people say a model's building block for computation. Should we see what the answer is? Okay, so you're right.
Oh, let's move to the next
That,
question.
yeah.
Okay,
So we
we
have
have
Saurav leading and followed by Mrinal and Avinash. Let's go ahead and see if the tables turn. Which activation function is commonly used for binary classification in neural networks? Sigmoid, ReLU, TAN, and softmax. Okay.
feel like tables are going to turn.
Yeah, tables are turning. I can see that happening right away. Very sorry, guys, but the answer is sigmoid. We can go ahead with the
What is
next
the
one.
purpose of the loss function in a machine learning model? To evaluate the accuracy of the model precisions, to compute the gradient unit of optimization, to measure the size of the data set, and to pre-process the input data. Quick. The table is really going to turn.
80% people have voted for the first one.
Shall we see the answer?
Yeah, go ahead. That's heartbreaking, man. To compute the gradient during optimization. That's the right answer. Only 20% of people have voted for that.
The
It's
tables are
fine.
going.
Yeah, tables are turning. You can see that happening.
Let's see the
Can we
next
see the
question.
leaderboard now?
We can. Let me just change.
Okay. I really want to see if things have changed or not in the leaderboard.
Yeah. Okay. Yeah.
Okay, so Saurav is still leading and followed by Priyanshu Panda and Avinash. Avinash is also in the game, right?
Yeah.
Priyanshu, you have come in to the second place. Everyone, please engage a lot. And Saurav, we hope you have the next questions right as well. And if not, Priyanshu and Avinash are all waiting for just to take over your place.
Cool, then
Okay, we
let's move to
can
the
go
next
to the
question.
next question.
What
Okay,
is
what
the
is?
difference
You can
in
go ahead. You can go ahead. Yeah.
when a model performs well on training data but poorly on new unseen data, when a model is too simple to capture underlying patterns, when a model has too many layers, when a model trains for too
Okay. Again, a tie. 33%. When a model performs well on the training data but poorly on new unseen data. And the other one is when a model is too simple to capture the underlying patterns in the data. What do you think is the answer, Swayam?
I guess the first one should be correct. I am actually even not sure about this question.
Okay, so it seems to be a tricky one, but let's see what the answer is.
Yeah, the first one is correct.
Nice one. So, this is
Yep.
the right answer. Yeah, we can go ahead to the next question. Which type of machine learning algorithm is used for making predictions based on continuous data target variable? The options are classification, regression, clustering, and reinforcement learning. We have 5 more seconds to go,
This is an easy one. Let's see.
and it's done.
Still,
45% people have voted for regression. I think that's the right answer, but
yeah,
let's see.
let's see.
Yeah, people are quite correct. We have some intelligent people right here.
What does the term epoch refer to a training or neural network? A measure of model's accuracy, the number of layers in the network, one complete pass through training data set, the learning rate of the model. Guys, this is an easy one. Answer quick, quick.
Okay, we have 43% people saying the number of layers in the network. And I can see the disappointment in your face, so is the answer not right? What do you think is the right answer
I
before we
feel
move
like
ahead?
the answer is the one complete pass through training set that I much I feel I'm a good, but let's see.
Okay, only 29% people are correct. Who click guessed it? One complete pass through the training data set.
So let's have a final view on the leaderboard. Okay, the tables have turned.
Yeah, they have indeed. Avinash has is leading the leaderboard, and congratulations, Avinash. We can't wait to see you and your guest audience way. So, uh, yeah, that's it. Congratulations. And we're really sorry for you, Avinash. Saurav, I'm really sorry. We can't wait to have you take some more quizzes and win in them. So, good luck for that. Avinash, congratulations for winning this one. Okay, so we are done with the quiz. I think it's time to have a little fun. Everyone watching here, you already know that we have a lot of events that we have already done, and the recent one was IO extended. So we think, Swayam, is it won't it be nice to have them all see the after movie of IO extended that was just released?
Yeah. So let's see the in the, like what we can say praise in the audience. So
So we would love for all the audience to watch our very new IO extended after movie, which has already been released. So let's go ahead and watch it. Yeah.
yeah.
Also, Abhinash, before we go ahead, if you can just drop your mail ID in the comments, we would love to share your award with you. Just share your mail ID here in the chat box. Yeah, okay, we can go ahead, Swayam.
Yeah, yeah.
Okay, so that was really nice. Swayam, you can unmute your mic.
Sorry, I didn't saw that I was on mute. Okay, okay.
Yeah, that was really nice. That was the latest event that we had. Uh, we hope you all enjoyed it.
I guess I can see the praise in the chat. So, did you like the after movie? And yeah, so we get heads up from the audience. I guess we can move to further sessions.
Yeah, we can.
So, up next, we have a true luminary in the world of tech and innovation. Here's AI software engineering manager at Intel, based in Bangalore, with a track record of turning innovative ideas into real world products in the fields of AI, AWS cloud, and mobile. Ani's ability to bridge the gap between cutting edge technology and practical application has not only just shaped industries but also inspired countless professionals.
Yeah. And today we have the privilege of hearing from him as he shares his insights and experiences with us on the topic Gen AI and stable diffusion optimization with Intel One API. So please join me in giving a warm welcome to the one and only Mr. Anish Kumar. Over to you, Anish.
Thanks, Anishant, and thanks, Swam, for the invite. Let me quickly share my slide. Let me know once you can see my screen. Can you see my screen?
Yeah, Anish, your screen is visible now.
Good. So thanks everyone for joining on this weekend, and I really appreciate you spending your weekend time to learn something new, and hopefully get something new to learn here from these sessions and carry forward it to your professional engagements. So, without much further ado, I'll introduce. Basically, today we'll be talking about the generative AI, a very brief introduction of generative AI, and then we'll have a short demo of how do you actually optimize the stable diffusion model with the Intel One API, right? And before I go, there's some short notices and disclaimer, and let me go to the introduction to I'll introduce myself. So as the speakers introduced me, I'm actually the AI software engineering manager for Intel at and I handle all the customers from the APAC region. And as part of my responsibilities, I actually engage with customers and developers like you to evangelize the Intel One API software tools, right? And we also closely work with customers engineering team to help they develop the AI some solutions that they might have. The AI solutions that they have might be at the very ideation stage, or might be at the POC stage, or maybe even at the say production stage. So we closely, our the Intel's engineering team and the customers engineering team closely work together and see how do we actually optimize the solutions to gain better performance. And as part of all those things, I engage in workshops, trainings, and tech talks like this to bring the knowledge of Intel One API to the larger audience. And the eventual goal is to bring the AI everywhere, to everyone, right? Everyone should be able to use AI. That's the overall goal. And I'm available on Twitter and LinkedIn. The links are flashed here. Do connect me over there, and we can continue the conversation there. And let me go to the next one. Yeah. So I will not talk about the technical aspects of generative AI. Probably most of you are already aware of all the technical aspects. What generative AI is, I don't have to tell what generative AI is, and what are the different options available. But before we actually go ahead and discuss the other aspects of generative AI, one of the common uh, discussions that we see, or the common news that is being flashed, or probably what you have been constantly be hearing is with the advent of generative AI, there might be potential job loss, or there might be potential jobs that might be replaced or taken over by completely by AI. One classical example that I can give is there's one popular photo editing software tool creator, as a company. It's a huge company, and they have around 43,000 employees, right? And when you compare those that companies with the Midjourney is a generative AI company which has pretty good AI models that can actually generate images out of your text prompts, right? And they have only 11 employees. And when you compare these two scenarios, and the news that you constantly hear in the market, what you feel that we developers might have a feel of a feeling that eventually all this the creative work might be like writing some text, right? Be it poetry, or somebody writing a lyrics, or somebody writing a contract document, or all this are creative works, right? And then maybe there might be an artist who's actually creating all the artistic things. Or there might be a musician like A.R. Rahman, or other musicians who are actually creating music. Or there might be uh, cinematographers, directors, and all creating all nice videos and all the things. But what with the advent of generative AI, what happens is generative AI is actually will be able to do all this kind of creative work that we have been seeing. And maybe like my personal assumption, personal take is, going forward, a lot of this kind of a creative work which involves generation of text, generation of image, generation of audio, that includes music, generation of video, will be taken over by AI, specifically generative AI, by generative AI. But that doesn't necessarily mean all these raw jobs, or the creative jobs are kind of becomes irrelevant. What I feel is all these creative jobs will be, the generative AI will give you more increased focus for the humans to give better value for the whatever work they do. Earlier, if somebody is taking, say, if I had to generate a legal contract document for one particular transaction, maybe usually it takes 2 3 days for us to generate all these documents, review it multiple times, get it vetted against by others, and things, right? But with the advent of generative AI, it doesn't mean that I'm totally eliminated as a guy who's actually generating a legal document. What the generative AI does is, it basically goes and helps you create the template, or the at least the basic structure of that document. And we as humans, I can like it generates it in like say 5 seconds or 10 seconds maximum. Usually it takes multiple seconds to generate a document. And once the document is generated, I as a human, I can just go do and high level review, and do small minor changes. So a work that usually was done in 2 days probably can be done in couple of hours. So what that benefits me is, like, I as an creative guy, probably I can use my extra time. So the instead of spending 16 hours on 2 days on a particular contract generation document, I spent 2 hours, and the balance 14 hours I could be invest in other creative things. I can actually do more value additions to the work that I'm doing. And all this we are doing by taking the advantages of the technology, the platform and tools that are being developed on a day-to-day basis. We hear on a day-to-day basis new language models are being released. Google has its own set of language models. Then Facebook has come up with their own large language models like the Llama 1 and Llama 2. And then there are many open source models like the Stable Diffusion that we are going to discuss today, or the Open Journey, and many other models. And all these things basically will help us a lot. And that's we are in actually a very good time zone, time period, where we are actually seeing the transitions of machines helping us, helping we humans in a very positive way, helping us enhance our value additions that we do. And one more probably one more classical examples that I can give is there was one large financial institution that even before the coming up of ChatGPT and all the other craze, this financial institutions was having like around 16,000 financial advisors, basically giving various kinds of advice to all the different clients of their clients globally. And what they internally did was they took a large language model, and basically they were working closely with one of the currently existing large language model providers. And what they did was they fine tuned that particular large language model with all the financial data that they had. Over these years they would have had large amount of financial data and all these things. They collected all these things, they fine tuned the large language model with that particular data that they had, and then they implemented guardrails and all these things. And then they took a set of 300 financial advisors and deployed this tool to them and asked them to use it and see how it goes. And what they saw was there was a tremendous improvement in the kind of financial advices they were able to give, and also the accuracy and the time to generate those kind of financial advisories were very fast. Instead of taking multiple weeks, it used to be half a day or less than that. And with that, this thing, what they did was they expanded the scope, and now they are actually planning to deploy it uh, entirely within their enterprises. What I'm all this trying means is now all the large enterprises will eventually start using different types of generative AI solutions. Uh, Say, for example, the big companies, big software companies might start using large language models like CodeGen. CodeGen is a large language model specifically for generating code and helping developers. And we already have multiple customers, or there's also a model called Star Coders. There are multiple customers working with this kind of large language model specifically targeted for developers, so developers like you and me, uh, and develop platforms that can help us write the code. What's the final advantage is, these large language models has data from all these years of work that all these many people have invested, and it is actually able to give you better solutions in a short period of time. And you as a as an experienced developer, you could actually go ahead and fine tune that, this review it and deploy your solutions faster, and add more value to the final work that you are doing. So the world is going in this way. Going forward, there's be lot of generative AI use cases across, disrupting multiple industries, not only the software development, but it's going to help the other industries like the banking and finance, healthcare, manufacturing, and you name it. And probably almost all the industries, definitely all industries will have some kind of a creative work being done. Creative work, it will be like text, image, audio, video, and all those things, right? Any industry will have some kind of this kind of a data being generated. And definitely AI, generative AI specifically, is going to disrupt all these markets. So with that thought, what I will encourage everyone is to learn all these new technologies, be ahead of this new technology, and try to master this, and help the set of new set of requirements that will be coming up your way, right? About more and more requirements will be coming into this kind of field. So learn all these technologies and be aware of this, and be a master, be relevant in the industry. So with that, I'll just quickly see if there is any questions. Hopefully I'm audible and all things are good. Okay, looks like, yeah. I'll continue. And before I talk about the stable diffusion, I'll briefly like to introduce to you to Intel One API. So in One API is an open source, cross-platform, cross architecture solutions, basically helping you as AI developers, or probably people who are working on high performance computing, with optimized set of libraries and tools and libraries that will help you, not tied up to a specific architecture, right? There are hardware, competing software solutions that are specifically tied to specific hardware. But they, with the Intel One API, Intel One API is an open standard. It's not, again, Intel is actually contributing to One API, and there are many other companies who are actively actually contributing to One API. And Intel has taken up this One API standards and actually implemented those One API standards across multiple libraries. So even though we all know Intel as an hardware company, but Intel also actively works on multiple software tools. And here in the screen, you can see this is common tools that we as AI developers might be commonly using, like the TensorFlow, PyTorch, or NumPy, SkyPy, Number, Pandas, all those things. Uh, the advantages of using One API for your development is, you are not tied to a specific architecture. You can, if you're developing your solutions, AI solutions using One API, uh, you have this guarantee that those solutions can run on a CPU, GPU, or any other accelerators of your choice, not only on the Intel but also on the competing hardware. So we encourage you to learn all these things. And for this particular session, we are going to use the Intel. So we will use the vanilla flavor of the TensorFlow and see how the stable diffusion works. And then we use the Intel optimizations for TensorFlow and see what is the performance gains you get out of these things. So along with this thing, we have like the Intel distribution for Modin, which is actually a replacement for Pandas. And some of our customers have seen multi-x improvement in performance when they replace Pandas with the Modin. And the advantage or the beauty of all these things is, basically, with one or two lines of code changes, you can actually have this optimizations implemented in your solutions and get improvements in your performance multi-x. Especially on the Pandas with Modin, or the SkyPy, or even for the PyTorch and other things, there are optimizations specifically implemented that targets using, say, for example, if you replace Pandas with Modin in your code with two lines of code change, what it does is, Pandas is generally runs, even though you might have, say, 20 cores on your CPU, Pandas generally runs on only one core. What Modin does is, Modin, if you use the Intel distribution of Modin with two lines of code change, what it does, it's going to actually use all the 20 cores in your machine, in your CPU, that you might have. And you get like a multi-x improvement in the performance. And similar use cases for Intel optimization for TensorFlow, or the Intel optimization for the PyTorch. You might be using a vanilla flavor of the TensorFlow or the vanilla flavor of the PyTorch. We recommend using the Intel optimization for the PyTorch on top of that, with just few lines of code change, and gain benefits of some of the accelerators that might be within your CPU, right? Say, for example, the latest 4th gen Intel Xeon processor has an accelerator called Advanced Matrix Extension, AMX. Basically, what it does, it's actually computes all this various matrix multiplication that's part of this AI journey into a much more efficient way. So we encourage you to use all this kind of optimizations and toolkits that are available. There's the link here is flashed, software.intel.com/one API. Go here, start, and it's all open source and free to use. Go ahead and use it, and It's available in various forms. It's available as an Intel installer or as a Docker container, or with the Linux installers like apt or m, or the with the conda. Intel also has a cloud specifically called Intel Dev Cloud. It's meant for, not for the general public. It's meant only for developers like you and me, where you can actually work on the latest Intel hardware for free. Some of the instances are available for free. We encourage you to sign up with Intel Developer Cloud, and I'll show you as part of this demo where you can actually sign up with the Intel Developer Cloud, spin up an instance and run your AI workloads on that. You can actually test your AI workloads on that and deploy it and test it with all the latest hardware. Both the CPU and GPUs are available. Use that. It's all available for you as for free for 20 days, and then you can keep extending it if you're continuously using it, right? And that's a pretty good options available for you as a developer. So do make utilizations of that. And before I jump into other slide, let me see if there are any questions. Okay, I don't have any questions. Let me continue, keep going. Maybe at the end we can stop for the queries. And now let's talk about stable diffusion. Many might be already be aware of what is stable diffusion, but for those who don't know what stable diffusion is one of the open source generative AI model. Specifically, it takes a text prompt and it processes the text prompt and can generate an image for you. Here, as an example, I'm giving, like, say, a photo of an astronaut riding a horse on Mars. I give this text prompt and it processes that this thing and spits out an image for you, right? And this is an image that never existed, and it actually created out of the training it had. But if you actually see from an perspective of there's another option also for stable diffusion. Like, you not only can give prompts, you can actually also give an image and a prompt, and then ask you to generate a totally new image. Here I'm actually giving an image of a person running in the woods, and then also giving a zombie running through the woods as a prompt. It spits out an image with a zombie, totally brand new image for that. But this is for from a perspective of an end user perspective or a non-technical person perspective. These are the options available. But we as developers, we are more interested on the technical aspect. What are the internal things that happens internally within the stable diffusion to do all this magic, right? If you see, stable diffusion inside has two major components. One is a text encoder, another one is called a image generator. So what this text encoder does is basically it takes your text prompt, a zombie running through the woods as a text prompt, and it actually converts that into a numerical representation called tokens. Right? It's called a vector token. Basically, it's a matrix of numbers that represents the prompt that you have given, and it takes that token and gives it to the image generator for you. And what the image generator internally further has is two different components. It's called the image information creator and the image decoder. What image information creator does is it takes a token from the text encoder, and it actually iterates through multiple steps. At each step, it actually generates a new image. It actually begins with an image with full of noise, and then it actually takes that, iterates through the prompt and see what's an image it can actually generate. Like, if you one of the configuration parameters when you actually are dealing with stable diffusion is the number of steps. Usually you can give 10 to any a number between 10 to 50 steps is a good number. Based on the kind of accuracy that you need, you can actually play around with those numbers for the specific use case that you are dealing with. So it iterates through that the process, and finally it generates an high quality kind of intermediate token that it actually gives to the image decoder. And image decoder takes that token from the image information creator, and basically it generates the final image for you. So if you see, internally, stable diffusion is actually a combination of three different models. There's an text encoder. It's the text encoder model is a clip text. It's again an open source model that is being used. And then there is, for the image information creator, there's a unit and scheduler model. that actually go iterates through all the different steps for the token that it receives from the text encoder, and generates an tensor that is being passed to the image decoder, and finally the image decoder generates you these things. So with it, this is covering a very high level. This is again, we haven't gone into the in depth, considering the time limit that we have for this session. What I will encourage is, with this basic knowledge, you can go ahead and explore more of this. And while encouraging you all to always try to get into in depth of things, don't just try to see how you can use a model or how you can use a particular tool. All you as developer, you and me as developers, actually need to actually get into the internal details of it, specifically for the generative AI. uh, Generative AI works, say for example, the prompts, right? If I give a prompt, say for example, a zombie running through the woods, if I, as a engineer, if I know what all the internal details, how it's actually working, I can actually give better prompts. I can know how the internally how it works. Then probably I can give a better prompt for it to work, give you better results, right? So that is one use case, one thing that helps you, but also it helps you in understanding what are the internal details, how you can optimize things and all the things. So encourage you to do spend time, attend workshops, go through. There are tons of YouTube videos explaining you the internal details of how a stable diffusion works, or maybe llama 2 model works, or try to play around with it. There are many options for you. There's an Intel Developer Cloud. There are collabs from Google and other things. There are many resources. We are all living in a very lucky time where all these resources, many of the resources are available for free, and it's only your interest and your passion is the limit for you. So use those opportunities, advance your knowledge, and do share those knowledge to others as well, and be relevant in the industry. So with that, we'll actually go with a short demo on how to optimize the stable diffusion model that is using TensorFlow. And like I'll run the stable diffusion model with TensorFlow, and then I'll use the Intel extension for TensorFlow, and see how there's a performance difference between these two different software stack running on the same hardware thing. You could run this on the Intel Developer Cloud. I strongly encourage you to all sign up with the Developer Cloud, or you could also alternatively also run on the Google Cloud C3 instances that are available. But again, it's a paid thing. You might have to pay for to use those instances. To begin with, maybe you can use the Intel Developer Cloud. Intel Developer Cloud is available here. Just search cloud.intel.com and do sign up. Like cloud.intel.com takes you to this page. Click on the getting started, or getting started, and do sign up. And once you sign up, you actually will end up into this page where you will be given a list of instances that you could use. uh, the second set of the first and this thing, the fourth one and the tiny are available for free for you to use. These are batch processing instances that are available for you to use. Just click on that and click launch instance, and it will take a couple of minutes, say 1 or 2 minutes, for the instance to launch. Once the instance is launched, you will see that instance in the view instances tab. So I have already set it up, and just going through some authentication, but it's pretty easy to set up. I'll also share this URL. This is the thing that I'm using. I'll put it up in the chat window. I don't know whether now probably somebody else can share this link. So I'm actually running through this example on the Developer Cloud machine, and this has complete details of how to sign up on the Intel Developer Cloud, how to use the Intel extension for TensorFlow, and then do all this experiment that we are going to do today. So like I said, go to cloud.intel.com, sign up, and once you land up here, launch this instance, and there is a short process on setting up an SSH access using public and private key. Go through that, and once you are done that, you can go and view instances tab, where you can see the instance that you are launched. And once the instance is launched, you can go ahead and launch the instance. And finally, using your terminal, you can connect to your instance, and I'll show you how to connect to that instance. And once you are connected to the instance, initially when you connect to the instance, it actually takes you to the head node. You might see your user ID and some name with the head node at the last. Head node is something you land into, but you might actually need a compute node, and there's a short command. You run this command in the terminal, in the same terminal, and finally what it does is it will take you to a compute node. So ensure that you are in a compute node before you do start doing your experiments. Right? Once you are in a compute node, clone this GitHub repository, and then cd into that directory. And once you cd into the directory, you run this command source prepare env.sh. What it does is basically it will create a conda environment and install all the software packages that are required. And once the packages are installed, and it will also run the Jupyter notebook. So you have this Jupyter notebook running on that machine, and you might have to do an SSH tunneling for that to access that Jupyter notebook on your local machine. So this again open up a new command line uh, window, and run this command, and you should have the SSH tunneling setup. Once the tunneling is set up, you can go to your browser and open that Jupyter notebook. So I have this set up here, and have the notebook open. And once it is open, it's pretty easy. I think most of you might be aware of what Jupyter notebooks are. But before that, let me show my thing, right? So I already logged into that machine. I have executed all the steps that was mentioned in that mentioned in this GitHub repo. Go through that. It's pretty easy thing. If you have at any point of time, if you have any issues, there's also a Discord channel available. You can join our Discord channel, where we will be able to help you on that. Or you can you have my Twitter link and a LinkedIn link. Post me queries there. Probably I'll help you. I'll redirect you to the correct forum where you could post all these queries. Right. So go through these 9 steps. You should be after the end of these 9 steps, you land into this Jupyter notebook page, where your Jupyter instance is running. So I have this compute node with the Jupyter server running, and then there is a one more tab where the SSH tunneling is being run. So I ran that command, SSH -l. I gave a local port, and then the IP address of that machine, and gave my credentials, and basically it's tunneling all that request from that server to my local laptop. So once this is successful, you should be able to see your Jupyter notebook, and you'll have this two notebooks, CPU and XPU. XPU will be for running it on the Intel Max series of GPU. So if you select this instance, it has both the Intel 4th Gen Xeon processor as well as the Max series GPU. Right. So you could run your solutions either on the GPU or on the CPU. For this particular session, I'm actually going to use the CPU notebook. The only change between these two are just 2 lines of code change, and there's not much difference in the code. Just 1 or 2 lines of code change to ensure that it runs on the CPU. But again, and this uses the one API standard, so you should be able to run it on any kind of a hardware, CPU, GPU, or even a computing hardware, or maybe your FPGA or any other things, or an accelerators you might have. And I opened that CPU notebook. Once I open this notebook, I have this notebook here. I'm going to install Keras CV, this particular version. You don't install the latest version for this particular thing. Yes, since you are also creating a Conta environment, just install this particular version, 0.6.1 as the version that is required for this particular lab. Use this, set it up. It takes a couple of minutes for you to install all the dependency and the Keras. And once that is involved installed, I'm going to set up certain environment level variables regarding the log levels and number of threads that I like to use and other things. And I'll start importing certain standard libraries, specifically from the Keras CB. I'm going to use the Keras CB models dot stable diffusion and other libraries, that is a pro library and other libraries that I'm going to use. I'll import it. If all goes fine, you see this kind of message you will not encounter. If you don't run this first one, probably you might encounter an error, but that's okay. Do give it's a trial and error method that you want to do. Try it out, and you should be able to get it up and running. And the Intel Developer Cloud already has the one API already installed. You don't have to specifically install the Intel extension for TensorFlow. It's already there for your machine. You don't have to specifically do anything additional. Also, if you are running CPU, ensure you are using this kernel, ITEX CPU. If you are running GPU, ensure you are using the ITEX XPU kernel. I know there might this actually we are getting too much into technical things. Some of you might not be able to catch up with some of the things, but that's okay. The idea here is to share knowledge and on the high level and understand what are the different options available for you as a developer, and then come to the Discord or supports channel to get further help from when you actually try it out to yourself, right? So don't worry about that. If you're not able to catch up with some things, like if you don't know what is Jupyter Notebook, or if you are finally finding any issues, we can definitely we are there to help you later. I'll share you the Discord channel. Come back to the Discord channel, and we can help you there. And then I'm actually defining a short method to draw a image, basically comparing the performances. That's it, and that's not of relevance for this particular demo. What is relevant starts from here, where I'm actually trying to configure the stable diffusion model with the vanilla flavor of the stable TensorFlow, right? So I'm giving number of iterations as one, and that I'm using the TensorFlow XLA compiler. I'm setting it to false, and the data type precision that I'm using is floating point 32. P32 is the precision that I'm going to use, and you'll see for the Intel extension for TensorFlow, we will be using a different data type that we'll talk about when we get there. I'm using a batch size of 1. And if you remember in the slide I showed you, the image creator has goes through iterates through a number of steps. It takes the token from the text encoder, iterates through the step. So here I'm giving the steps as the 50, and then there is something called seed value. Seed is basically if all the other parameters and seed value is same, for a given prompt always generates the same image. But if you want for a given prompt the stable diffusion to generate different images, try to give a different seed value, so you end up with a different images. Probably later, if I have time, I can show you that demo also. I set up this parameters, and then I set up the stable diffusion model. And once this model is set up, and I give a prompt. A prompt is a photo of an astronaut riding a horse on Mars, and I'll do a warm-up session so that when we are actually comparing the results, it's better to do a warm-up session so that all the caching, memory, everything is loaded properly, and we don't account for those loading times into in our final calculations. So I do a warm-up session, and then I do the actual inference. And if you see here, without any optimizations, internal optimizations, with the warm-up session, it took around 141 seconds, and running an inference, it took around 127 seconds, right? With FP floating point 32 as the precision, right? And it generated an image. This is the image it generated. It's pretty nice. For a 50 step, it's almost nice. There's some discrepancy here in the lag and also, but that's okay. It's only thing probably you might have to improve your prompts. The better you improve the prompts, the better is your results. And now what we do is, now we'll go and use the Intel extension for TensorFlow. That is, we import that Intel extension for TensorFlow on the developer cloud. If you are using the Intel dev cloud, this is already installed. You have to just import it. You just write this one line of code and it's already there. But if you are using GCP C3 or your any of your local machines, probably you'll have to install the Intel One API extensions, Intel installers. You could use that. There's also one more way you could do that. I'll share this link to you. Use this link if you have, based on these things, like say for example, I'm doing an inference optimization. Select inference optimization, suggest what are the tools to use. Say for example, suggesting you to use TensorFlow and PyTorch, and you could go ahead and download the offline installer directly. Or if you need any additional things, you could you download those things, download it. I'll share this link here in the chat. Please do share it in the, for the audience. Use this configurator. Yeah. And configurator will allow you to download those packages for your local machine. If you're using developer code, don't worry about those things, and just go ahead and import that. And I have imported the Intel extension for TensorFlow, and I'm actually setting up certain options. I'm basically using the bfloat 16 as the data type precision. And also setting up the auto mixed precision options, right? What it does is, Intel Xeon 4th gen processor, the Sapphire Rapid processor, has an AI accelerator called Advanced Matrix Extension (AMX), and what it does is it will actually enhance the certain computations that are specifically required for this AI workloads. And we are basically using bfloat 16 data type all and enabling those extensions. With that, we'll see, you should be able to see an improvement in your inferencing time. I'll enable that with this simple changes, five or 10 lines of code change, and then I set up the configuration and rerun the same thing. I'm just again taking up the model, same stable diffusion model, do a warm up, and do the inferencing. Now, when I do that, if you see, it actually for the warm up, it took around around 88 seconds, and for the image generation using the bfloat 16, it took around 91 seconds, right? When you actually compare this with the result, and the image is almost same, there is no change in the image finally it is generated. Both the optimized version and the vanilla flavor generates the same kind of image. And if you see, it's all running the same thing, and it gives you pretty good performance improvements, almost like there's 30% or close to 30% improvement in your performance time. And if I plot it, you could see a difference, right? With the FP32 and vanilla flavor of this thing, and with the Intel extension for TensorFlow, you will get pretty good optimizations. So this actually ends the demo. So go through all these things. Encourage you to go to one API or use the AI configurator link that I gave you. Go here, download these things. Use the optimized source. Don't just use the normal version of PyTorch or TensorFlow. Use the optimized versions of this TensorFlow and PyTorch, or all the other libraries that I discussed earlier. And also encourage you to sign up with the developer cloud. This is specifically meant for developers like you. Use this for your advantage, gain more knowledge on all these things, and be an expert, improve your skills on these things. So with that, probably I can come to a conclusion. Yeah, you have seen the performance improvements, and that's actually ends this demo. If we have any specific questions, probably I'm open to the questions now. Meanwhile, if you are interested in stable diffusion or other things, there are a lot of other tools also. There's something called Invoke AI. Google up Invoke AI, GitHub, land into this page where this is again an open source front end user interface for you to use Stable Diffusion. It gives you a nice front end where you can give the prompt and set up all the parameters and run it locally or run it even on your dev cloud machines or cloud machines, right? Use this. There are a lot of other libraries, additions to Stable Diffusion. So encourage you to all explore all those things and take benefits of this open source software stack. So with that, I am open for questions.
Yeah, Anish, there are a number of questions from the audience.
Sure.
Uh, so let's start with Kumar Shivan. So Kumar Shivan is asking, is a stable diffusion different from GAN?
Yes, Stable Diffusion. I mean, finally, they all actually serve the same purpose. But Stable Diffusion, the technique it uses is a diffusion technique, where it actually you breaks up a noisy image and slowly generates the final outcome. So we don't have to worry about that, whether it's a GAN model or some other thing. These are different types of ways to approach a solution. You should be as developers probably need to be aware of all these things. Good, that's a pretty good question. So yeah.
Cool. Before moving to the next question, Anish, can you check your camera? I guess you're not visible to anyone here.
uh, okay, sorry about that. Let me check. I'm not sure, there might be some setting issues. Let me check.
We can drop it, like if it's causing an issue, we will just continue.
Okay, I think there's some issues with the camera.
Cool, cool. No worries. Let's move to the next question.
Yeah.
So next question is from Adarsh. So Adarsh is asking, you see the image you gave and the image generated by AI is a more of an animated one. So how can we make it more realistic?
Uh, okay. Okay. Is my screen still visible? Yes, I
Mm,
think it should be visible. Let me see if I can quickly run.
yeah, your screen is visible.
So just give me a moment. I'll quickly run the Invoke AI on my machine and show you some of the images that looks very real, right? I mean, it's um, not only kind of looks animated, but again, it's all depends on the prompt that you give. See, actually, I tried to generate. While I set up this, just what I'm trying to do is I have set up all the dev cloud. I'm trying to log into my machine. It takes a couple of seconds to log in, and if you see, I'm in the head node, and then I'll switch to the compute node. I'll run this command. It takes me to the compute node, and then I have the invoke AI here, and I'll run. Let me start the invoke AI. Before I start the invoke AI, let me take the IP address of this machine. The IP address of this machine is 24, and then I will start the invoke AI. So again, all these commands are available in the invoke AI GitHub link. Now go to that. You should be able to get all these things, and it takes couple of seconds for it to run. Um, So and once it runs, I'll show you the kind of images it actually generates, right? It actually generates a very good images that are looks very realistic, right? Or you can actually also Google up in the interest of time. Probably we can just the openly available things. So you just search like stable diffusion prompts. Mm, and all these images are actually generated by stable diffusion. I mean, some of them looks animated. Again, it's all based on the prompt that you are giving, right? Like a pop art painting. If your prompt is like that, you might get something similar to a painting. But you also get a very realistic things. Let me quickly see if I can pull out some. Yeah, this also looks very realistic. The prompt is like a portrait photo of an Asian old. Okay. Yeah, these are like this actually looks very realistic. It's actually comes very close to yeah, real. Definitely prompts, stable diffusion, or all the other open source models can generate images that are very realistic. It looks real. Not only can generate images that looks like an animation or animated thing, but it can also generate an beautiful image that are very realistic. So do explore that. Again, it's like I have couple of prompt examples here, right? There are a lot of prompt examples, like say a high fashion photography, portrait photo of a Swiss female model with blue red hairs. Just give try to this again is all you need to play around with the different prompts that you based on the prompt that you are giving. It actually generates a different images for you. So to answer to your question, stable diffusion or any other models like the OpenGenie not only can generate images that looks like animated, but it can also generate images that looks very realistic, and you might not be able to differentiate between the stable diffusion generated model and others.
Cool. I guess that
Okay.
solves it for the Adarsh. Anish, there's another question from Tech Society Triple ID Bhubaneswar. How
Hmm.
can one effectively understand and interpret the outcomes of a generic algorithm in the context of solving complex organ optimization problem?
So is it did he mean genetic algorithm or generic?
Genetic.
Genetic.
Yeah.
I'm not sure if he actually meant genetic, but if you are meaning to use generative AI for some kind of a molecular research or genetic research, definitely you could use that. And there are a lot of research organizations and enterprises already started using it. And definitely you could use it. But again, you need an expertise. You might not be able to straight away use a models that are open source available. Take that open source model. Say, for example, you could take a Llama 2 model and take the Llama 2 model, and then probably you need to fine tune it. What I will recommend is if you are targeting for a specific use case like genetic engineering, genetic research, or say banking and finance, or insurance, or manufacturing or healthcare, take a Llama 2 model, say 3 billion parameter model or a 7 billion parameter model. Probably 3 billion parameter model should be good enough. Take those smaller models, fine tune that model to the custom data set that is specific for the industry that you are trying to target, right? So you as an a researcher working on genetic engineering or specific things, you might have a lot of data set with you. Say for example, Intel is working on silicon manufacturing all these various silicon hardwares like the CPU, GPUs, and accelerators. So over this years, Intel definitely I will have a lot of this data sets. Intel can take those data level within the enterprise and can fine tune some of the large language models and basically help in further research or help in increasing the productivity of the engineers. This is just an example, and I didn't mean that we are doing that, but I'm just giving an example of what's the possibilities. So don't go. Also, one thing probably you might have to note here is don't go with the hype that you might have to use an 100 billion parameter or a 1 trillion parameter model for your enterprise use case. Just have this thing in your mind. Say, for example, in the ChatGPT, ChatGPT came up and it was using the ChatGPT GPT-3 model. It was 176 billion parameter model, and that 176 billion parameter had data from the beginning of human history, from the written history to till the date it was trained. So the entire human history could become can be loaded into a 176 billion parameter model. And if you are have a company like say a 100 years old company, even if you are 100 or 200 years old company, the amount of data that you might be generated can be fit into few million parameter or at most 1 billion parameter thing. So take up a 3 billion parameter open source model like Llama 2, and then use the data that you might have and fine tune it. Don't go with the craze that you might need an 500 billion parameter model or 1 trillion parameter model for your enterprise use case. If it's a generic customer use case, the end user use cases like chat gpt or something, definitely you might need a bigger model. But for most enterprise, so for almost all enterprise use case, you can begin with a smaller model, like the genetic. If you're doing a genetic engineering research, take all the data set that you might have genetic engineering. It might hardly fit into few million parameters, right? It will not even go into a billion parameters. Take that and fine tune that with the open source model, implement all the guardrails, and you should have a, pretty good model that actually can cater to your needs.
Hmm. We have last two questions, Anish. One is from Avinash Mishra. If stable diffusion creates an image from a complete noise, then what happens to the input image? How is the given image correlated with the noise that it creates?
So stable diffusion has two ways, like I said, that has two different approaches to generate an final outcome image, right? It can actually take just take the text prompt and then it generates kind of an noisy image, and from that noisy image it tries to decode into an actual image that you might be seeing. Or the other way is you might have to give an starting image, like the demo I showed you. I might give an image of a person running, and what it does, it takes the, it knows that from the prompt that it might have to take only that person as the this thing, and maybe like the person is running. So it will take that person's characteristics, whatever the characteristics in there in their input image, and will finally try to blend that into the image that it is generating. So, to answer to the question, it's basically it will take certain inspirations from the input image that you have given, and finally it combines with the final image, the final image encoder decoder component you saw, the third component that you saw in the internal working of the stable diffusion. It actually merges that into give you the final outcome.
Okay. Next question is from Kumar Shubham. Hi, can you give me an insight how DALI works? Is it the same you discussed or different?
Dali is also very similar. This thing, I mean, Dali is also a model that gives you similar things, right? Basically, you give text prompts, it can generate an image for you. Um, Dali, I think it works on a different. Internally, the working is slightly different for Dali. I don't know the exact details, but it's slightly different from how Stable Diffusion works.
Cool. Another question from him only. How do we guarantee safety and privacy while creating with such types of images?
Okay, these generative AI models per se will not give you the safety and guarantee safety or privacy things. In fact, all these generative AI models can be prone to privacy issues or safety issues. So, you as an enterprise, like I gave the example of the financial institutions, they not only fine tune their model, but they also have you. One of the things that you have to do is basically implement the guardrails, right? Intel has certain tools and technologies to do that. If you can actually Google responsible AI, There are things for that. There are guidelines on how to have a very responsible AI in terms of ensuring the privacy and security things are all taken care of. There are multiple approaches. You might have to implement those approaches in your pipeline to ensure the security and the safety and privacy concerns are taken care of. There's also a tool called a deep fake catcher. So Intel has a tool called deepfake catcher. It can actually detect the images that are actually generated by AI. It can differentiate images generated by AI from the realistic images. So there are multiple tools like this available in the market. So based on the specific use case and domain that you are working on, you might have to implement those guardrails. That is a pretty critical part of this entire pipeline. It's not only developing the solutions, but implementing guardrail. That's a very good question. I think you should be doing all those things. There are multiple ways to do that.
Cool. There's another question. There are two. I guess it's with the in response to the query you solved. Abhinash Mishra is saying that we can use LLAM A2 7B chat HF for end use cases as well.
We can use Llama to 7 billion chat Hugging Face model for end use cases. Yes, you need to apply for a license. It's actually Llama 2 model is from Facebook. You need to apply for that license. Once you Facebook gives you that license, read through the terms and conditions of the license and see if it actually meets with your corporate guidelines. If it's meeting, go ahead and use it. Uh, for most of your generic evaluation, this shouldn't be an issue. I have applied for it. They have granted to me, and we are internally. I'm also internally evaluating it. So you should not have any problem for end use case. But again, I'm not the legal expert on that. There are legal private things. Facebook has its own legal this thing for using how you can use Llama. Talk to a legal expert. They might be able to help you based on your internal corporate policy.
Great, great. I guess that solves everyone queries. Thank you so much, Anish, for joining in today. It was a remarkable one, or
Yeah.
indeed,
Thank you,
y'all.
thank you, Swayam, and thank you, Keras Community Group, Bhubaneswar, for having me today. And thanks
Sure.
everyone for joining me on a weekend and spending your precious time for this session. Thank you.
Thank you, Anish, for you to spare a time for us on the weekend. I guess with that we will be proceeding to through the event. Let's just give me a sec. So till then, since my team is loading the rest of the slides, can you have in the chat box how did you guys like the event so far? Everyone in the audience who have been interacting till now. Anyone? Okay, I'm getting a lot of responses from. It's very delightful to see all your great messages. Thanks, others. Thanks, Sasa. Thanks, Tech Society Triple I. Thank Avinash. Thanks, Sangram. Thanks, Varsha. Team, can we have the next slides up? Yeah. So moving on to the last session of the day. Up next, we have Mr. Suryanshu Dash, an AI enthusiast and dynamic developer from Bhubaneswar. He has a strong interest in machine learning and artificial intelligence. Suryanshu's relentless pursuit of exploring new technologies has led him to build industry-leading solutions that transform the way humans work and solve complex problems. Suryanshu is passionate about AI, machine learning, and artificial intelligence, and he is passionate about building innovative solutions that solve real-world problems. Suryanshu, over to you.
I guess Swayam is having a little issue. Next we have Suryanshu Das. He is an AI enthusiast and a dynamic developer from Bhubaneswar with a strong interest in machine learning and artificial intelligence. Suryanshu's relentless pursuit of excellence in software engineering and his enthusiasm for learning new technologies has made him a valuable asset to the tech community. We're privileged to have with us today and for him to share his insights they promise to inspire us all. So today he is here to say his valuable insights on TensorBoard and its use in ML workflows. So over to you, Suryanshu.
Uh, Hello, am I audible?
Yeah, you're audible. You can go ahead.
Perfect, perfect. Thanks, Anisha. Hey everyone, just a shout out to Anish and Prejaj. Really loved the sessions and the topics you spoke about. It was really insightful for you, even me. So, yeah, before we start, just wanted to know the audience a little bit. So, can you guys tell how whether you guys are college students or working professionals and so on? Just wanted to know you guys. Okay, okay. So it's pretty much a mixed audience. Great. Cool. A little bit about me. So currently, okay, I'm a graduate of CET Bhubaneswar in the year of 2022. I recently joined Newton School as a data science manager after 1 year of a job experience at Scalar. Newton School is again a tech platform where mostly I manage a team of three or four people. Uh, we have our own AI products where we use GANs and all to create better experience for students. And yeah, pretty much that's it. So before we start this, I just wanted to know, have you guys heard about this term tensor board? Like, it's mostly a college student crowd I can see. Yeah, so tensor board. Okay, Abhinav says he's using it. Cool. Okay, got it. So you must have definitely come across this term of tensor board, right? What about TensorFlow? It's a very because I guess most of you should have heard about TensorFlow, right? Since Keras is part of the TensorFlow framework. Okay. So, for even for those who have not heard about it, it's fine. As the session progresses, we'll get to know what is TensorBoard and so on. Okay, cool. I'll be sharing my screen now. Just a second. Just give me 1 second. Yeah. Can everyone see my screen? The slides. Perfect. So let's start with the session. Since this is the last session of the day, and I guess you guys must be already at the peak of what you can digest as a human, so it's fine. We'll go slow and we'll try to see all the terms in what can be used at TensorFlow. What is the same? Acha, before I start, just wanted to know what is ML workflow? Like, can you guys give me a simple definition as per you? What is machine learning workflow? You must have heard machine learning is a very common term, but what is this workflow thing? Okay, the process to build and deploy. Okay. Anyone else? What does one mean when he says machine learning workflow? Or any workflow in general? Like, workflow is a very common term. So, what do you mean when you say workflow? Okay. Yeah. Great. Mostly, as Kumar Subham said, yeah, the steps exactly. So basically, the steps we take, the whole process of taking the data, collecting the data for a use case, business case, then clearing the data, processing the data, passing it through the machine learning model, and tuning it. So this is the whole workflow, and then again monitoring and analyzing and keeping on check so the model does not actually get obsolete. So that's the whole machine learning pipeline or the machine learning workflow. So where did tensor board come in? So at this last step, when we have already created the model and we are trying to deploy it and we are trying to tune it, in that part, TensorBoard is actually way more useful. So what is actual TensorBoard? So as you can see, TensorBoard is a very it's TensorFlow's in-house visualization tool. So once you have created the model, you need to understand like how can we improve the model? What should we do? So like we can improve the parameter, we can clean the data more. Like where is the problem lying? If the model is giving 80% accuracy and we want it to be 95%, is the problem with the model? Like should we change the model? Should we tune the model? Is the problem with the data and so on? There are a lot of factors involved in this whole workflow. So exactly understanding what is the root cause of this, of the bad performance of the model, we need to understand the metrics and parameters and how the model is created. So to understand that, to visually understand that, we use TensorBoard. Because seeing the numbers, like if the model is given 80% accuracy, 30% loss, or let's say RMSE score of 0.34, that does not actually give us an idea of what are we seeing. But seeing something visually actually gives a way more clarity that how should we improve or how should we go about it. So TensorBoard actually is useful for that. It helps us to visualize the whole model because people usually say machine learning is a black box. We just give the data, we get the output, but nobody actually knows what is going on inside the model. To understand the depth of that black box, we use TensorBoard. So yeah, exactly what is TensorBoard I won't be saying. As we like during the demo session, when I actually try to build a TensorBoard, you will get to understand like how these things actually relate. Okay, so features of TensorBoard. As I said, machine learning is a very black box kind of model. To understand uh, the box, this whole thing, like what is this model? What is going on inside the model? How is the model learning? What are the things which the model is trying to like use to understand the relationship between input and output? We use that to understand that thing. We use TensorBoard. It gives us summaries, the graphs, the visualizations, and so on. It also it has a lot of features like when I show you the demo you can actually understand the number of features, the actual power of TensorBoard and how we can use it to leverage into our machine learning models. Okay. uh, Again, like I won't be keeping this session more texty. I will directly be jumping into the code because telling you guys in theory what is TensorBoard is not actually going to make much sense. So I will actually create a model in the session and integrate TensorBoard there and show you like how it's done. So yeah, uh, any host is there, Anisha or someone? Just wanted to know how can I share my tab?
Hi, Shanshu. You can just
Yeah.
like In the bottom bar, there would be an option to present. If you have
Okay.
done that, just do that. After that, team will add your presentation to the screen.
Okay, just a second. So I should go with sharing the whole screen, right?
Whichever is comfortable with you, sharing the whole screen or the presentation that you have made.
Okay, okay, perfect. Okay, just give me 1 second. I'm
Sure,
sharing the
sure.
screen. Okay. Yeah, 1 sec. Application window. Yeah, can you just like make it that everyone can see the collab screen?
Yeah, your collab screen is now visible to everyone. You
Perfect.
can.
Guys, wanted to ask a question here. Like, have you guys ever used Google Colab? Ever tried this platform? Okay. Google Colab or Jupyter Notebook, either of them. Just wanted to understand, like, have you ever worked in this kind of environment? Okay, so I guess most of you do know about Google Colab, right? Be it Google Colab or Jupyter Notebook, you guys definitely have worked with this kind of interface, right? Great, perfect. So, can someone tell me like what is Google Colab? Since most of you have worked with it, can you give me an idea like what is Google Colab and why it's better than Jupyter Notebook? Like both are there, both have the same kind of functionalities, Jupyter Notebook and Colab. So why do we prefer Colab, or why should we go with Colab? First on Google Cloud, yes. Yes, what I was looking for was basically this, that GPUs and TPUs part. So yes, generally not many of us have the systems to, because machine learning models require a huge amount of computation. So to be able to handle that huge amount of computation, we use some Google Colab because it has GPUs and TPUs inbuilt. It's a cloud-hosted notebook platform, like where we can actually run our models on Google's own provided GPUs. That makes it very easy for us to train our models. Cool. Let's start with it. So TensorBoard is actually, it's a browser-based EA. So when you try to, it's a complete dashboard. So rendering a dashboard on a notebook is not simple. We use when we use a do it in Jupyter Notebook, it as you know, like Jupyter Notebook opens a whole browser window for you, right, to work on it. So similar to that, it again opens a port for where the TensorBoard is hosted. So if we want to use it in like Google Colab, we have to load the extension of TensorBoard. So how do we do that? Let's say we have to load the. I'll just zoom in. I guess it's not visible much. Yeah. Extension. So we will use this magic operator. We can use any kind of like rendering service for Google Colab using this magic operator percentile. .txt TensorBoard. Okay. Then we'll be importing the nested libraries. Definitely TensorFlow. Okay. Have you guys heard about MNIST data? MNIST. This data. Have you heard about it? MNIST. Just a yes, no is fine. You just need to understand like whether okay. 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 Cool. Okay, most of you have heard, most of you have not. I'll just show you it in little glance. So this is basically MNIST data. It contains images of numbers and the respective labels as 1, 2, 3, 4, 5, 6, 0, 8 to 9. So it's a very classic data set which is used in deep learning frameworks to actually train a model to understand or predict numbers based on their image. It's a very useful application even in NLP and so on. So yeah, we'll be using a kind of extension of this MNIST data only called Fashion MNIST. So again, who like have you guys heard about Fashion MNIST? Also, I would prefer if you guys can actually open your Google Colabs and start coding with me. That would actually be useful. Yeah, I will just show you guys what is Fashion MNIST, so that will make much more sense. One sec. You scale the data to, you know, make it less heavy on the model, and standard like scaling the data actually has its own purpose usefulness. So yeah, now let me actually show you what PLD might show. So each of these data points actually contains an image. So if you can see, what is this image? This is basically a, everyone can answer this, right? Like what is this? Yeah, Lawrence and exactly. Coursera has really good yeah, Lawrence has really good courses. Yeah, it's a shoe, boot, pretty much that's it. Shoe, correct. So what does fashion image exactly contain? Yeah, that's exactly it. It's a shoe. So as you can see, it has fashion apparel. So if I like type say to 23rd or 24th image, again that would be a, even I don't know what this is, like a code or something, I guess. Let's go with 5. So this is a jumper jacket, if you can see the full sleeve ones. This is a t-shirt, or you can call it a shirt too. So yeah, what fashion image actually contains is basically data of different kind of fashion apparels. And since machine learning models are basically computerized models, they need to have some kind of numerical labels to understand. So for this value, the actual value of the it, the output will not be actually a shirt; it will be a label. So, okay, sorry. Yeah. We'll change here. Yeah. So basically, when we say extreme 0, as you saw on the wrong bracket, yeah, yeah, as you saw, all told, this is a shoe. So the label for shoe is 9 here. So all these labels are actually computed in this data only. So we don't need to actually manually do the label encoding for this. Cool. Okay. Now, since we already know what the data is, let's create a very simple model. Since we coding the whole model, are you guys actually coding with me? Just wanted to know. Like who all are parallelly coding with me? And like, is the session going very fast or is it fine? Okay, you are on mobile, no worries. Perfect. Since yeah, I'm just sending you since you'll be creating a model, I already have the code for this, so I'll just paste it here and create the model. I'll be sending the same on chat also, so you can like copy it from there. Keep in mind the indentation because Python is a very indentation based language. Just give me 1 second. Yeah, I'm sending this code in chat too, so you can just. Since YouTube has a character limit, so it's divided. But try to maintain the indentation when you're writing this code. Okay. Going ahead now, since we already have created a model, now we need to understand how to integrate TensorBoard in it. TensorBoard, we already loaded TensorBoard as an extension. We now need to understand how to actually make it part of our model so that it's able to track all that's going on and how the training is going on in our model. So for that, we'll be again creating a function to train our model, and then we'll be creating a callback. So what are callbacks? When we are training a model, the model actually tries to refer to a callback to store any kind of data or try to store the data as per the required callback. So we can name it a TensorBoard callback. tf.keras.callbacks dot TensorBoard. In the directory for the logs, I will be providing it in, let's say, logs. The optimizer I'm using is Adam. I will tell in a while. I will show you what's the like how creating using different optimizers can give us different results and how we can actually track that even. And let's keep the histogram frequency as 1. Okay. Now let's fit the model. Again, I already have this code, so I'll just be pasting it here. The training data we're providing as X again, and the testing data as Y train. The number of epochs we will be taking, let's say 3 epochs. The validation data would be expression Y test, and the callback will be our TensorBoard callback. Now finally, we will call our train model function. Is everyone with me till now? It's a simple process. We have just created the architecture and trained the model on this, and just one parameter we have added, the callback. Yeah. Now, till now it has been not much interesting because yeah, this is mostly lines of code. But now what I'm going to show you is actually make you understand why we did all this. What is the power of actual TensorBoard? So we'll just give a directory of the logs. It's logs, and we stored it in Adam. So logs, it will actually create a different directory for. Now when we run this, give it a moment to complete the training and render the TensorBoard. So this is your tensor board. We'll just convert. Are you guys fine with dark theme or do you want this to be in light theme? What do you prefer? Chat. What should we go with? Light theme or dark theme? Okay. We're just waiting who would say light. So yes. Cool. So as you can see, the training data and testing data, it has given us two plots for each. So if you see the training is actually increasing, the accuracy is actually increasing from it's around 83% and it's going till 86.5% and it's still increasing. So it gives us an idea that okay, we can keep on increasing the epochs and it's not saturating at a point. So this is one thing. The second thing is the loss again. It gives an idea that the loss is still decreasing. So this is the first kind of data. The scalars give us the data in a very, like if you're training multiple models, it will show us multiple graphs here to give us an idea. Okay, this is training and this is testing. Now coming to what is this black box? I told you guys about what is machine learning black box, right? Like it's a model which we are giving the input, we are getting the output. We don't know what's going on inside the model. This is how TensorBoard helps us with that. So this is the whole machine learning model and the whole path it took to train itself. It looks very jargonous, but let's go on little component to understand it. So if you remember, we used sequential to create a dense model, right? So if you can see, there's a sequential tab here. If we double click on sequential, this opens up the sequential. So we are able to see each component and we're able to expand that too. So again, in sequential, we use two dense models. If I go up, you can see in sequential, we used two dense models and a flattened model. So what does flatten do? The images are 28 cross 28. It flattens the image into 1D array. And then the neural network is formed by the dense layers. So this sequential part contains these things. And if you can see, each component is like listed out here as layered or dense, dense and flatten. So again, we can go into each of these components to and understand them. So if you double click it, you can see the flatten has multiple things. It's getting a constant and it's getting an iterator and it's passing it through each shape and again dividing into length layered or dense. If you click on layered or dense, you can see this is the path which layered or dense took. And again, if we click on gradient tape, okay, I guess in the dark mode it's not visible much. Let me just make it into light mode. Yeah, so you can see this is highlighted. When I click on gradient tape, what happened after the model passed into gradient tape? From there, which path it took? Where did the model go? It shows us the whole the whole schema of that. So again, we created a model, we used flatten, then we went to dense. So after this, it goes into dense. And if you can even see, like this is the tensor which is going. It's 32 cross 784, which is going into the next layer, which is the dense layer. Now, if you double click on dense, give me a second, I guess my browser, yeah. I'm zooming out a little. So yes, what happens inside the dense layer? The output is coming from flatten, it's getting multiplied, then a bias is added, and then it's being passed to the next layer. So again, you can see each component in very depth here. You can see what is happening inside MATML. You can see what functions are being called. You can see what are the calculations which is going on and so on. And similar for bias addition, like you can see which functions are called, what is the bias added, and what is the kind of, like if you see this is a scalar which is going, this is the number of parameters which are going and so on. So what the sensor would actually show us, this is the whole machine learning model, the three layers, the three lines of code which we wrote, this is the whole part. But how it's under the hood, what's the, like what is the connections, what are the connections going, what is the output going, the dimension, the everything, every details of that we are able to see using TensorBoard. And again, this is the optimizer we are using. So if you want to understand how the optimizer is working, you can again double click on that, and it will give you the whole Adam optimize, like what is happening inside it. So it like this one three lines of code, you're able to break it down, you're able to spread it out, you're able to see each part. It's like you take a globe, you take a map of India, and then you're able to see each country, each like each state, each city. What is the map? Everything you're able to see, and that gives you really more power. You a real depth understanding of how the model is working. I guess everyone is clear till now. Guys, are you able to see my screen, right? Like how the maps are opening up when I click on these parts, and how I'm able to show you what's going on inside each hood. Because there are a lot of component machine learning. We only write 2 or 3 lines of code, but there's a lot of computation going on inside. So if you really want the full power, if you really want to leverage the full power of machine learning, you need to understand what's going on inside, how every nut, every bolt, every screw is working, and how tuning each one of them can affect a model. Cool. Perfect. And then I will just show you the histogram. So we use 3 epochs, right? So in each epoch, what are the distribution of the tensors? What are the distribution of the weights? The weights are basically what? They define the relationship between the input and output variables. So how the weights are distributed in each epoch, that is shown in the zeroth epoch. The weights are distributed in this format. Like the values range from around 5.44 to 977. In the first epoch, it's going to a very low value. In the second epoch, it's even one exponential minus plus 3. So it gives us a distribution of all epochs. And in each layer also, in Adam train, the dense 2 layer, kernel 0 layer, bias layer, and every layer, dense layer 2, and so on. Cool. And again, you can, like, this is currently a step value. You can again make it relative. You can validate. You can use the overlay type to actually see this kind of data. And yeah, mostly that's it. Again, there are some features which you can use in your collab. There are some features which are not available for collab, for which you have to use the Jupyter notebook. In Jupyter also, once you the process still here is same. Once you are till training the model, after that you have to just write this command in your command prompt, and that will open up the tensor port in your own in your port. Let's say if you want to open it at port say if you want to open it at port 6006, which is the default port for TensorBoard, you just have to write this notebook dot display port equal to 6006, and height equal to, you can set the height and width as per you. But yes, that's it mostly. And based on this, you are able to, like, you know, before that also you need to yeah, just from TensorFlow import notebook. So this will open up the notebook in your set format. Right now, it's this is something which you can use in your Jupyter notebook. So you just run this code in your Jupyter notebook, or let's say in your Go command prompt, and you'll be able to open the A in the port 616. Okay. I guess you guys are able to understand what till now, right? Like, is everyone with me till now? Are you able to understand what I'm trying to say here? Like how this black box can be opened and actually each component can be seen in minute details using TensorBoard? Okay, perfect. Yeah, I'll be sharing this notebook if you want to post this post this session, so you can just refer to it if you need to understand how to integrate TensorBoard in your model. Cool. Coming back to the slides. Yeah, just switch it. Yeah. Okay. Just want the host to actually like host the slide window in the screen. Yeah. So, what are the use cases of TensorBoard? As you saw, the first use case which we saw is completely monitoring with deep learning training. We can use the parameters, like let's say we can understand whether we should continue the training process, or whether we should stop, and where the issue, as I said at the start, like whether data is the issue, or there are some parameters which are creating problems, and so on. So we can actually understand this training process using TensorBoard. Second thing is in image classification, object detection analysis, we can see, like we can actually even visualize the images. So when we use larger ImageNet models, like if we use CNN and so on, and or we use RNN for natural language models, we'll be able to understand how and where are the like how the inputs are like transforming throughout the model, and it will actually like mostly it allows the researchers to explore into the depth of this machine learning model and understand like how we can modify each part. So mostly that's it from my side. Like in conclusion, you guys know that how TensorBoard is actually useful and how we can actually use it to improve a model, to train our models, and it's always a good. It's just a single line of code, and but that single line of code gives you so much in-depth insight into a model that you will again start thinking, okay, this is how it's happening, and this is how we can change it, and so on. And it's not only TensorFlow; you can also integrate with frameworks like PyTorch and so on to like irrespective of any kind of framework you're using, TensorBoard can be integrated anywhere and mostly in any kind of notebook. So yeah, that's it from my side. Thank you everyone. So do you guys have any questions?
Cool. That was a nice one, Suryanshu. Thanks a lot.
Thank you.
Just let us check the questions. Then we
Yeah.
are good to go. Okay. Uh, guys, if you have any question, please drop them.
Thanks, Vash. I have shared the link for the Collab notebook. So if you guys want, you can just refer to that.
Shreyanshu, I guess your link is not there, not yet there. If you get
Okay.
repost,
Just sharing it again.
like
Yeah. Can you check it again? Uh,
MS, yeah, the link is now, I guess, available. Yeah,
Perfect.
cool.
Acha, so I'm just sorry. Yeah. So can you just let like show my slide once again? Just one last thing.
Your slides, right?
Yeah, yeah.
Okay. I guess my team will do this one. Anyone from the TFUG who is handling the slides right now? Which slide you want to open, or I just give access to your presentation?
Yeah, it just gives you access to my presentation. That will be
Okay,
fine.
you start presenting. They will add you to the studio.
It's already there. Like it's already yeah. So if you guys want to ask anything or connect with me, these are my social handles. So you can just connect with me on LinkedIn or for Twitter also. It's the same.
Cool.
Cool.
Great. I guess we are getting appreciation for your session, Shreyanshu, Rupesh, Mohanty, Varsha. Cool. Then I guess with this
Yeah,
we come to the
that's it.
end of today's session. That was a nice one,
Thank you,
Surya.
everyone. Thank you, TFUG, for having me.
So
Sure.
with,
Thanks, everyone. See you.
let's move on to the wrap of the session. Uh, so finally, as we come to the close of this exciting and insightful journey at Keras Community Day 2023, it's an honor and a privilege to extend our heartfelt gratitude to everyone who has made this event a resourceful success. First and foremost, we would like to express our deep appreciation to our incredible speakers, Virjat Singh, Anish Kumar, and Suryanshu Dash. Your expertise, passion, and willingness to share your knowledge have been driving force behind today's enlightening sessions. Thank you once again for all your inputs. A big shout out to our partners. Without your generosity and commitment to the tech community, events like these wouldn't be possible. We would also like to thank our organizing team, the TensorFlow User Group Bhubaneswar, GDG Bhubaneswar, and GDG Cloud Bhubaneswar. Your dedication and hard work behind the scenes have ensured seamless execution of this event. A special thank to all the attendees for joining us today. Your enthusiasm and active participation have created an engaging atmosphere that truly embodies the spirit of the communities and collaboration. We hope you all leave here your valuable gains in knowledge and connections that will continue to benefit in your AI and ML journeys. As we conclude this event, let's carry forward the knowledge and inspiration we have gained today and continue to explore the limitless possibilities of AI and the world of artificial intelligence. Thank you once again. We look forward to seeing you in future gatherings. Have a great, wonderful day ahead. Thanks a lot.